Digi-Arsenal Hardware Description Language and Overview. Digi-Arsenal is a hardware description language primarily available on Android devices. The application software is beginner-friendly, easy to understand, and simple to use. Users can utilize the app to understand, study digital logic, and design on the go. Functionality of the app. Various devices have been implemented for usage. Devices include both combinational logic and sequential logic devices. There are approximately 30 devices implemented in the app and a handful of commands to utilize the devices respectively. The bits can be accessed individually with respect to the standard array accessing index method in computer programming. The entire set of bits can be accessed by their respective names as a bus of bits. Kindly refer to the Digi-Arsenal command book for commands. 7 primary gates AND, OR, NOT, NAND, NOR, XOR, XNOR are available, and in this app they are considered as individual devices according to the syntax of the language, and the output bits of the respective gates are available to be used individually. Adders and subtractors include half adders and half subtractors, full adders and full subtractors, variable bit capacity binary parallel adders, variable bit capacity binary parallel subtractors. The respective sum, carry, difference, borrow bits can be used individually and as a bus. Combinational logic devices. Variable bit capacity N to M decoders with both high active and low active functionality. Variable bit capacity demultiplexers with both high active and low active functionality. Variable bit capacity N to M encoders with priority mode and first active mode. N to 1 variable capacity multiplexers. The respective output bits can be used individually and as a whole. Sequential logic devices include RS flip-flop, JK flip-flop, D flip-flop, and T flip-flop. Variable bit capacity registers with shift left and shift right functionality, parallel load functionality, variable bit capacity counters with up down counting modes, and parallel load capacity. Variable bit magnitude comparator of two sets of bits with output bits of greater set, similar bits, and different bits. The respective output bits can be used individually and as a bus. Bit access using a bus. There are a collection of bits called bus. Buses can be used to access the various output bit sets of various devices, for example, the sum bits of a parallel adder. Buses can be used to access the bits individually of various output bit sets of the devices. Buses can be used to combine different bits, for example, one output bit of a device with the output bit of another device and use them. RAM, ROM, and PLA. RAM with variable MN capacity, ROM with variable MN capacity, programmable logic array. The data stored in RAM and ROM can be accessed to print the values and can be used in other devices in a form of bus. For example, read, row index, bus name will return the output set as bus, and read bit, row index, bit index, bus name will return the bit in form of a bus. For the purposes of development of a community, there is a repository Digi-Arsenal in our GitHub profile, Computational Labs -code. In the repository, the user can submit for update request if they feel the necessity of a feature or device support, and they can submit the request in issues of the repository. If they find a bug, that needs to be fixed, it would be highly appreciated if they submit a bug report in issues of the same repository. The user can submit their programs in GitHub in issues program of the same repository. The command book will be available to download from the repository in GitHub. There is a dedicated Discord server for the users to have discussions. There will be a Hall of Fame section in respect to the user who makes an essential update request or a critical bug report. All the respective links are available in the video description. Thank you. When you click the GitHub link of the repository, you will see issues, and when you click create new issue, you will see the 3 templates to choose from: bug report, program submission, update request. You can choose your templates according to the scenario. Here are the templates for the reference. Let us consider some sample programs for referential purposes. In this program, we have a half adder AC and a full adder ACD. We serve the sum of AC as the A bit of the ACD full adder. In this program, we have a parallel adder AB of 4-bit and a parallel subtractor of 5-bit. We serve the sum input set of the adder to the subtractor A set. In these programs, we have a decoder, a demultiplexer, an encoder, and a multiplexer, and we demonstrate the usage accordingly. In this program, we have a register of 4 bits, a counter of up counting capacity of 4 bits, and a comparator of 4-bit, and we load the register and the counter parallelly, and we compare the data of the register and the output of the counter using the comparator. Here we have the RS flip-flop, the JK flip-flop, the T flip-flop, and the D flip-flop, and we demonstrate the usage accordingly. Here we demonstrate a RAM with 4 and 5 sizes. Here we demonstrate a ROM of 4 into 5 sizes. In this program, we have a RAM, a adder, a subtractor, a register. We feed the sum bit set of the adder to the A set of the subtractor. We then store this difference of the subtractor in the row 1 of the RAM, and then we access the row using a bus, and then we store the bus as an input to the register.